All right, today we're going to totally change how you look at algebra. Seriously, forget just memorizing a bunch of rules. We are going to become strategic thinkers. Because solving a problem isn't just about finding an answer, it's about finding the smartest, fastest, most elegant path to get there. Let's dive in.
So think about this for a second. You've got all these pros doing their jobs. What's the one thing they might all need to find? Is it a starting point? Maybe a break-even point? Or is it the absolute highest or lowest point of something? Well, the answer is, it totally depends on the job they're trying to do. And that right there is where our strategy begins.
I want you to picture a Swiss Army knife. You know the one. It's a single object, but it's got a blade, a screwdriver, a little can opener. Each one is designed for a very specific task. Well, algebraic expressions work the exact same way. You can write them in different forms that are totally equivalent. The real magic, the pro move, is knowing exactly which tool, which form, to whip out for the specific problem you're facing.
So let's grab our first tool from the kit. I like to call this one the ground level tool. It is perfect for any situation where you gotta know when something hits zero. You know, like a ball hitting the ground, or a business finally breaking even on their new product.
Okay, so get this. These three forms, they can all describe the exact same situation, but they shine a spotlight on different pieces of the puzzle. For those ground-level questions, like finding a break-even point, we need the factored form. And why? Because look, it's the only one that just hands you the zeros, those little r values, right there in the formula. No digging required.
Let's make this real. A ball gets thrown, and its height is modeled by this equation right here. We want to know when it hits the ground. So what does hitting the ground actually mean in math speak? It just means the height is 0. So our job is to find the zeros of this expression. And guess what? We have the perfect tool for that job.
Okay, so you crunch the numbers, maybe you use the quadratic formula, and the math spits out two solutions, a positive time and a negative time. And this right here is where you level up from just being a human calculator. It's a classic trap. The math isn't wrong, but the real-world context tells you to throw one of those answers out. I mean, come on, can time be negative? Of course not.
And boom, there it is. The ball hits the ground after about 4.16 seconds, a perfect job for our ground level tool.
All right, tool change time. What if we don't care about when something hits the ground? What if our job is to find its absolute highest point, or its lowest point? For that, we need a different tool. We need the peak and valley tool, vertex form.
Let's take on a new job. We're designing a suspension bridge. That big cable hangs in a perfect parabola, and for safety reasons, we absolutely have to know its lowest point. The job isn't about finding zeros, it's about finding that minimum value. Now, a lot of the time, the equation will come in standard form, which kind of hides that minimum point from us. So we've got to reshape it. This process you see here is called completing the square. Look, don't let the name scare you. Its one and only job is to transform that standard form into the super useful vertex form. It's like tuning up your tool before you use it.
And this is where the magic happens. Look at the left, standard form. It tells us the starting height of the cable is 10 meters. That's cool, but it's not our goal. Now look at the right, in vertex form. The answer is just sitting there, staring you right in the face. The vertex, our lowest point, is at 20,2. It's just handed to us on a silver platter.
So the lowest point is 2 meters. We didn't need any extra calculation. That is the power of choosing the right tool. It does all the heavy lifting for you. Okay, let's put our quadratic tools away for a second and pick up a different kind of multi-tool. This one's for problems that look really simple on the surface, but are just loaded with hidden traps. We're talking about rational expressions, which are really just fancy fractions with variables in them.
So here it is, one of the most famous puzzles in all of math. It looks so innocent, but I promise you it trips up almost everyone who sees it for the first time. We're going to figure out the average speed for a simple round trip. So picture this. You drive to a friend's house at 40 miles an hour. Later, you drive back along the exact same road at 60. What's your average speed for the whole trip? Now be honest, the first number that just pops into your head is 50, right? The average of 40 and 60. But it's not 50. And this is such a great puzzle because it actually uncovers a really deep truth about what an average even is. So why is the simple, obvious answer wrong? Here's the secret. It's a time waiting trap. Just think about it for a second. Which part of the journey takes more time? Driving there at 40, of course. And since you spend more time driving at that slower speed,
That slower speed has way more influence, more weight on the final average. It literally drags the average down from 50.
The real answer is 48 miles per hour. See? Just a little bit under 50, exactly like our logic told us it should be. It's not about memorizing a formula, it's about understanding why.
Okay, here's another classic mistake with these fractions. Everyone sees something like x plus 2 over x, and their brain just screams, cancel the x's, but you can't do it. I love this pizza topping analogy. Think of it like this. The top part is a pizza with cheese and pepperoni. You can't just scrape off the cheese and call it the same pizza, right? You can only cancel things when they are factors, meaning they're multiplied by the entire top and bottom.
And all of this brings us to the main event. We've used a ground level tool, a peak and valley tool, and we've navigated some pretty tricky hidden traps. The goal of all of this is to level up from just being a calculator to becoming a true strategic problem solver.
Okay, this slide right here, this is your game plan. Before you even start a problem, you just have to ask yourself, what information do I actually need? If you need to find break-even points, you grab your factored form tool. If you need a maximum or a minimum value, it's vertex form all the way. And if all you need is the starting value, good old standard form has you covered.
I want to leave you with this idea. This is really what separates the beginners from the pros. A sophisticated problem solver doesn't just know the formulas, they know which form is going to give them the most insight with the least amount of work. They're efficient, they're elegant.
So I'll leave you with this question. The next time you see an equation, don't just jump in and start crunching numbers. Just pause and ask yourself, what's my goal here? And which tool in my algebraic Swiss Army knife is the perfect one for this job? Thanks for hanging out with me.